Similarly, we have other functions like np.rint. So as the name indicates, whatever I am going to give inside the parenthesis will be converted to an integer. So I'm just going to give here 123.456. Okay. In this case, it will not accept an additional argument that specifies the number of decimals. Directly, this will just give the integer only as value. And what it will do is, it will just check after the decimal value, if it is 5 or more than 5, 1 will be added to the integer part. Otherwise, it will just, the integer part will be displayed as such. So here 1, 2, 3 will be the answer. And now we shall go to np.fix. And I'm just going to write here 11.2. Okay. So when I give a decimal, the decimal is converted to an integer. An integer that is nearest to 0. So which is the integer that is nearest to 0 means 11 will be the answer. So in case if I give here 11.8 also, it just gives us 11, because 11 is the one that is nearest to 0. The same way here, I can just give np.floor. So in this floor, I'm just going to write 12.5. So in this case, what will be the answer means? So when I give 12.5, you know that 12.5 is a value that is lying between 12 and 13. So in this case, 12 will be considered as the floor, and 13 will be considered, the higher value 13 will be considered as the seal part. So when I ask np.floor of 12.5, the answer that will be returned will be 12, since that is the lower value. So here the answer is 12.0. In all these cases, what you have to make a note is, it is returning the integer part, but the integer part is returned, but the output is given in the form of a floating value. The same way here also, the floating value is given as the output. And suppose the same thing if I just do for seal. So what I can do is np.seal, and I'm going to give here 12.5. So as I told you, 12.5 is something that is lying between two values, 12 and 13. So for that, the seal or the upper value will be 13. So 13 will be returned. Done. So the next thing what we have to do is the same thing we can do with negative values as well. So here we can say minus 12.5. So in this case also minus 12.5 is lying between minus 13 and minus 12. So in this case, minus 13 will be considered as the floor, and minus 12 will be considered as the seal part or the higher value. So when I give the output for this will be minus 13.0. Yes, the same holds true here also for seal. So if I give here minus 12.5, so the answer will be minus 12. Okay, we are done with this. Now we shall move to absolute function and fabs function. See, absolute function and fabs function, both of them will return the absolute value of the parameter whatever that you give as input. So in this case, if I write here np dot, I can write here absolute, and then I'm just going to give minus 12, minus 10. Okay, now let us see the output. The answer is 10. So the minus value is being excluded and just the value 10 is given as output. Suppose I am going to give here 10 np dot fabs. So fabs also, I told you that this will also return what? The absolute value of a number, but let us see, there is a small difference. Fabs will return the absolute value of a number in decimal form. So this is actually 10.0 in decimal form. And one more difference between these two is absolute can handle complex values. Like, I can give here np dot absolute. I can write here 5 plus 6j. So I can give the complex value here. It just gets handled. It calculates and it comes out. But the same thing, if I try to do with fabs, it will just come out with an error. So basically, fabs will not be able to handle complex numbers. So this is what we get in fabs. Okay, and then we have some functions like exponent and all. So you can try it out. Exp of 10. So when I give exp, that is basically e to the power of 10. So the same thing we can do it with exp2 of 10. Okay, so this also gets calculated. So it is basically 2 to the power of 10, and that the value comes in float. And then you have the same thing, you can calculate the logarithmic value also of any particular value can be calculated. And you also have here log 10, and you also have log 10 to the base 10. So that value can also be calculated. And then you also have log 10 to the base 2. This is also calculated. Okay, so we saw basically exponent, and then exp2, exponent 2, and then we saw log, and then log to the base 10, log to the base 2. And now we have some more functions like, square. So np dot square. So basically it will square whatever you give inside the parenthesis. So this is get 66. And you also have something like, square root. So sqrt of 6 is also calculated. I'm sorry, it is sqrt of 6. So here this is also calculated.